This dredging operation removed thousands of tons of silt and sand that needed to be relocated. A Delta levee project needed huge amounts of earth to complete its repairs. With a little ingenuity and coordination, one project's liability became another project's asset. It's a Department of Water Resources strategy called beneficial reuse, designed to reduce costs. This placid body of water is Clifton Court Forebay, located at the southwest end of the Sacramento-San Joaquin Delta. It's part of the State Water Project's Delta facilities. Water is temporarily stored here until it is lifted into the California Aqueduct by the Harvey O. Banks Delta pumping plant to begin its journey to the Bay Area, Central Valley, and Southern California. Water entering the forebay comes from upstream releases from reservoirs and uncontrolled runoff. As it flows down rivers and delta channels, the water picks up sediment that is eventually deposited into Clifton Court Forebay. If not removed, the sediment reduces the forebay's storage capacity, increasing the power costs of delta pumps. A recent dredging project to remove the accumulation of sediment reaped enough material to fill 270 football fields to a depth of 1 foot. The nearly 500,000 cubic yards of material, once considered a problem, was put to practical use by another project sponsored by the Department of Water Resources. Engineers at DWR, working with other agencies, created a plan to use the forebay's unwanted materials to help strengthen weak Delta Island levees. To remove the sediment at Clifton Court, suction dredges operating like huge vacuum cleaners moved across the bottom of the forebay, drawing a mixture of about 20% sand and 80% water. Laser instruments guided the dredging, helping the operators to stay on course. A floating pipeline transported the dredged material and discharged it into barges, or released it into a temporary stockpiling area. On the barge, the soupy mixture was allowed to settle, and much of the water was pumped off. As the mixture settled at the stockpiling area, it was pushed into piles and lifted by a clamshell dredge to a nearby barge. Tugboats moved full barges through 20 miles of delta channels to Twitchell Island.
You know, Twitchell had one of the worst levees in the delta. Everything that could go wrong with the levee was going wrong at Twitchell. We had slumps, we had cracks and leaks. In 1991, the levee was so bad that high winter tides were overtopping the levee. But the good news is that we were able to use high-tech evaluations to determine the causes of all these problems and then design innovative solutions at a cost considerably less than had previously been estimated.
The solution for Twitchell Island included constructing a 4-mile-long berm on the land side of the levee. The completed berm is at least 60 feet wide and 8 feet high. The added weight against the levee significantly reduces the possibility of levee movement during unusually high tides, winter storms, and even earthquakes. The levee's increased strength also helps protect water quality for over 20 million Californians and safeguards thousands of acres of valuable wildlife habitat from permanent flooding. The fortification occurred over a 4-month period on the Island South levee, where the watery sand mixture was dumped and spread out. After it was dry, the material was graded, compacted, and seeded to help protect it from erosion. To complete the project, an all-weather road was put on the levee's crown. During the Twitchell Island project, some trees had to be removed or protected. In a mitigation agreement with the Department of Fish and Game, trees were planted to create over 3 acres of riparian wetland habitat on the island. A retaining wall was also constructed to protect trees that otherwise would have been removed. Twitchell Island was the first delta island where the beneficial reuse strategy was applied. The results have been so successful that planning for other beneficial reuse projects is moving forward.
Well, this beneficial reuse project has established a new level of understanding that will open many doors in the future for successfully protecting delta levees using unwanted dredge material. We've had a real success story here. We've been able to fix one of the worst levees in the delta in an environmentally sensitive manner at a cost less than previously been estimated.